Now, in every example we've done so far, the thing we've been looking to find has been on top of that fraction. But what if the thing I'm trying to find is on the bottom of that fraction? Let's try a couple. Okay, here's a right angle triangle. Let's label sides. Oops, I lost all my bits. Let's label the sides. Here's the hypotenuse, it's opposite the right angle. This side is adjacent to my angle. And I'm not going to bother labelling this, it's opposite the angle, but I don't care. Alright, which of my three trigonometry ratios involves adjacent and hypotenuse? It must be, let's see, AH, always hide, can't always hide. Cos of my angle is adjacent on hypotenuse. Alright, let's have a look. Put in what we know. Cos 58 degrees is 18.6 divided by W. Oh, now the thing I'm looking for is on the bottom of my fraction. How can I get it to the top? Before, I was multiplying by what was on the bottom, and it ended up here on the top. So if I just multiply by W, I'll get W on the top. W cos 58 degrees is 18.6. See what I did? I just moved the W up to the top, the same as if it was a normal number. Okay, now I've got W times this, and the opposite of multiplying is dividing. So I'm going to have W being 18.6 divided by cos 58 degrees. As long as you're careful to remember that cos 58 is one thing, it's a function, take that, divide everything on the right by that function, you'll be fine. Look what I actually did. I got my 18.6 and I just swapped these two around, didn't I? W on the bottom here becomes W on the top over here. Cos 58 on the top becomes cos 58 on the bottom on the other side. Effectively, this is called cross multiplying. Effectively, this is like a little seesaw, and what's on the bottom on one side can become the top on the other. You just swap them around. Okay? But if you get stuck, you can do it in 2 steps like I did here. Alright, got to this point, get your calculator. Because you've got W by itself, so you just go 18.6 divided by cos 58. And that is 35, what have I got, centimetres. Let me write these down. It's 35.099686. That'll do. Let's have a look. This is centimetres. I probably just want one decimal place. The next digit is more than 5, so you have to round up. It's going to be 35.1. Too easy. Okay, last example. Let's have a look. Label the sides. Well, that's the hypotenuse, but I don't care. This side is adjacent to my angle, next to it. This side is opposite my angle. Okay. Which trig ratio involved adjacent and opposite? Old age, their old age. Tan of my angle is opposite on adjacent. Put in what you know. Tan of 5 degrees is opposite divided by adjacent. 120 divided by P. Okay? P is on the bottom, I need it on the top. So the bottom on this side, drawing my little seesaw swap again. Bottom on this side, we're going to multiply up here and get it on the top up here. And top up this side, tan 5 degrees, we're going to divide by it and get it on the bottom down here. Swap them around, cross multiply. Okay? So you get your calculator, you get 120 divided by tan 5. It tells me it is 1371 point. Oh, I got meters. But this wasn't very precise, was it? I'm guessing probably the nearest meter would do. 606, etc. You need to look at the context of the problem. The question might tell you what accuracy to use, how many decimals, or to the nearest whatever. Or look at it. I've got 120 meters, no decimals, nice round number. Let's go to the nearest meter. The next digit is a 0.6, so we'll round it up to 1372 meters. Simple as that. Of course, when you get better at it, you don't need necessarily to label the sides, but I'd recommend you do to begin with.